Hi and welcome back. In the last lesson we were working on designing this tic-tac-toe game right here. It would ask for the location for the player 1 to mark a spot, let's say 2, and then if we press 2, player 1 is given the letter X here, so it would mark X on the spot chosen by player 2. If player 2 chose the same spot, for example, it would say no, you can't move on because you still need to mark the spot. And let's say we give it the right order. We keep going, eventually player 2 wins because I marked 3, 5, and 7 with player 2. So that's diagonally all O's, so player 2 wins. So let's look at the code. Let me just refresh the page till it comes back. Okay, so as you can see here, what happens first is I set each row in the board to be a list by itself. I gave them numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and the three lists are part of a bigger list, which makes up the whole board. Then I have another variable called ended, which is set to false. This variable is used to keep the while loop, running. The second I see that someone has, won, or when I check if someone has won the game or not, I set this to true, and then the while loop stops running and the game ends. Then I print the board for the first time right here. I have to print the board, I just print out whatever each row is holding. So I print out the first row because I know there are only going to be 3 items in each list. I just print out the first letter, add some space, print out the second item in the list, and then print out the third item in the list, and I do this for all 3 rows. And then this is optional right here. I just did this to make the board look a little like pretty. You don't need this. If I delete it, go ahead and do that right now. It will look just as fine. I mean, it doesn't have the same like visual appeal, but it works. So that's that. Then we move down. This is where the while loop starts. So I'm counting the number of moves that the player has made. I divide that by modulus. I divide that by 2, get the remainder, and then add 1 to it to see which player's turn it is. So if at the first move, the moves is set to 0. Right here, moves is set to 0. It starts off at 0, so the remainder is going to be 0. Then I add 1 for player 1, and then it's just gonna tick-tock between 0 and 1, 0 and 1. But since I'm adding 1 to it, it's gonna tick-tock between 1 and 2, 1 and 2, 1 and 2. Then we have the location here that let me just make this a little bigger. Then we have the location here that I asked the player to input, and then I store it as an integer. Then after that, this is where we check. This is where we are checking whether we can mark the location or not. Since I know there's going to be 3 items in the first list, and then there are going to be 3 items inside the second list. So this right here goes over the 3 lists, which are each one of them is an item in the big list, right? And then for each of those items, let me see what happens if I just do this here. So print board I. Okay. So every time, let's see what happens. Let me stop it and run it again. So let's say I say 2. Look, it prints out the first list, then the second list, then the third list. This is what board I is, right? Because look at board. Each I is going from 0, 1, 2, and 3 because of the range function. Range 0, when range gives out 0, when I is 0, it prints this out, and then this out, and then this out. And then through each of that, let me just call this row. So let's do that. So we have rows here, and then for each row, I have the location, right? Let me put this inside the print as well. This right here is the location in each row. Inside the print. And then look what's happening. So if I select 1 now, it's going to select the first row. It's going to go through each of the locations in the row. It's going to 1, 2, 3, and then it's going to move on to the second row, 4, 5, 6, and it's going to go through each location in the 4, 5, 6. Now, what's happening here is the board is checking the location that the user entered. If that location is on the board, then it If it's player 1, it marks it X. If it's player 2, else, so it's not going to be 1, it's going to be something else, it's going to mark it with an O. And every time it marks it, it also adds 1 to moves right here. So moves initially is 0. So let's print this right here. If board is location, we're just going to print moves as well. This is what I meant when I said that moves is such a powerful function. It basically gives you, like, I don't know what moves is at any given point, but with this function right here, I will know exactly what it is. Let's see. So if I say 1 now, look, at first location, moves is 1. But since I've already marked it, since I marked it 1, it added 1 to moves as soon as the location was 1, and then it didn't do anything at the other locations because it checked whether moves is 1 or not. Now if I enter move again, if I enter 1 again, see, there is no moves printed out. That means it never went inside this because 1 is not an option in the list anymore. So it never added a move to the moves variable. And since it never did that, it never added, it never changed the player because move stayed the same. So the player, if it's player 1's turn, that stayed the same as well. That's how I checked whose turn it was and whether the location that was used, whether the location that the user entered is a valid spot or not. Then we move on to, once again, this is exactly printing the board again. Now since I want to print the board every time the user enters an input, I want to print the board again every time. Now this looks daunting, but it's actually just one couple of lines of code repeated over and over again with different locations to check. So the first one is checking 0, 0. So this is 0, 0 right here. It's checking whether this number and then 0 and 1, which is also which means the first row and the second column. So first row and the second column will be 2, and then first row and third column would be 3. So this is basically checking the first row if it is equal or not. It's just checking whether the characters in the first row, all the characters in the first row match. If they match, then we know that the current player that's playing right now has won. And I can set end it to true, and I can say player, whichever the number of the player is, says wins. I do the same thing again with the second row. This is, look, the 0, 1, and 2. These are the columns. They stay the same, but I simply change the row this time around. Look here. Then it's going to go from the first row, second row, third row. Then I change the columns. Similarly, I change the columns. Now the column stays the same. I set them to 0, and then I change the rows. So now I'm checking 1, 4, and 7, then 2, 5, and 8, then 3, 6, and 9. And then in the last one, I check diagonally the last 2. So this is 0, 0, 0, 1, 1, and 2, 2. So this would be the first row in the first column, second row in the second column, and third row in the third column. That's what this is checking right here. And this is the one checking diagonally, but in the other direction. So this is checking 3, 5, and 7. Third in the first row, third column in the first row, second column in the second row, and first column in the third row. And that's what this is doing. So there are supposed to be 1, 2, 3, 4, 5, 6, 7, 8. There's supposed to be 8 ways that you can check, that you need to check whether the character is the same or not. So 1, 2, 3, 4, 5, 6, 7, 8. There you go. So there are 8 things that you need to check. And look, I have elif right here because the first one wins, then I don't care what happens to the rest. I don't mind, like if the person wins by putting the first row together as well as the second column, it doesn't matter to me because the person has already won because of the first row. And this is also I didn't talk about this one, but this was kind of obvious. After all the players have marked all the spots, then there's not much the person can do. We just say if the moves have equal 9, which is because of the 9 spots that you can mark. If the moves has now 9, that means that the game has ended and no one has won. Like in this case, it would print out that the player has won, but in this case, it just says game ended with no one to win. So I hope that was simple and clear enough to understand. I will post the solution in the description so you can have a look at the code there. And let's move on to today's lesson. In today's lesson, we will be looking at functions. This is the most important aspect of programming. Let's have a look. A function is basically a block of code by itself. You can assign a name to a function and execute that block of code by simply calling its name. You can call a function multiple times anywhere in your code as long as you have defined the function before calling it. The way you define a function is to first write def, short for define or definition, followed by the name of the function, then a set of parentheses, followed by a colon, and then the block of code that you want to associate with that function. To call that function, we simply write the name of the function along with a set of parentheses. Let's look at an example now. To write a function called print to 10 that prints numbers 0 to 10 every time it is called, we write def print to 10, a set of parentheses, and then a colon. In the block of code for the function, we write a for loop with a range function that iterates over numbers 1 to 10, and then a print function to print those numbers out. To call this function, we simply write the name of the function along with a set of parentheses to call it. As you can see, functions can make programming a lot easier by not having to write code over and over again. However, we can also make functions return values. Return statements make functions even more powerful. They allow functions to return a value as well that can be assigned to a variable. To return a value from a function, simply write return and the value after it. To save this value to a variable after calling the function, simply use the assignment operator and assign the call of the function to the variable. Keep in mind though, the return statement should be used at the end of the block or when you expect the block of code to stop executing. The return statement exits the block of code as soon as it is executed. Since the return statements only exit the block of code when they're executed, you can have multiple return statements in conditional blocks, and only when one of them executes will you exit the block of code. If no return statement is executed in the block of code, Python will still return a value of none, which is of type none type. None type only has the value none, and that's its only use, to specify none. In Python, you cannot leave a block of code blank. It will give you an error. Sometimes you don't know what to write yet, or you're simply testing or debugging something. In those cases, you can just write pass instead. Pass doesn't do anything itself. It just lets Python know that there's going to be something here, but for now, just skip over it. Pass works for any block of code. You can write it instead of a block of code for a function or instead of conditional blocks too. You can even write it as a statement anywhere in your code without affecting anything. Let's now try to code all that we learned today. So, in today's lesson, we learned about functions. Let's see how we can make functions help with our code. Let's say we have a list called X, and then we are holding 1, 2, 3, and 4 in it. And then we can, if you want to print values in it, this is what we've been doing so far. Print X. Let's see what happens. We print each value in X. That's what each is holding. It holds one value in X at a time. And that's what happens. Now, if I want to write this code like 5 times, I'm going to have to copy it and paste it, which is kind of like redundant, since if I write this code again and again, I'm bound to make a mistake, and I don't need to do that. That's where functions come in. Let's say we have a function called print my list, parentheses, and then we make this a block of code. We do that. Now it's a block of code. Let's see what happens if we run it now. As you can see, nothing happens. That's because even though we defined the function, we haven't really called it. So if we call the function now, let's see what happens. It prints out this thing. Now the beauty of functions is I can call this function as many times as I want, right? And now look what happens if I make a change in one place in the function, right? Because I realized I want to add a space, I just make one change and it's implemented every single place where the function is called. That's why functions are so important in Python and in any programming language for that matter. Now sometimes you don't know what you're going to write yet, so let's see what happens if I leave this blank, right? Python gives me an error. It's saying, okay, the next block of code, the next statement after this, after the colon needs to be indented, but there's like nothing here. So it gives me an error. It says, okay, indent this, but I can't do that. That's not what I want to put inside the block of code. So in that case, we just put in pass. Pass is basically telling Python that there's something supposed to be here. There's going to be something here in the future, but just skip over it for now. If we run it now, it runs fine. It doesn't do anything, but it doesn't give you an error either. Pass also works as like a statement. You can just put it anywhere in your code, and it doesn't affect your program at all. It's just a blank statement that's basically saying do like nothing. Now, we talked about how we can make functions return a value as well. So let's see how we'll do that. Let's say I want to call this function give me 10, and take a guess what this function is going to do. It's just going to return 10. Let's see what happens when I call this function. Take a guess. Let's see. Well, nothing happens because it's the same as like just writing 10 in your code. That's going to do the exact same thing. Nothing's actually going to happen, but we can assign this value to something, right? So let's say I say give me 10 is now assigned to x, and then I can go ahead and print x, and now x is holding 10, right? So that's what happens. If we call a function with a return, it returns the number that the value that is returned gets assigned to a variable that uses the assignment operator on. Now what happens if I don't write anything? Let's just say all this function does is just print something. It has no return, right? It's not going to do anything. Let's see. Let's do this. Okay. So let's see. It prints 10, but it doesn't return anything. Look at x now. X is holding none, and we can even print the type of x. Can get rid of this list for now. So look, it belongs to the class none type, and the value that it's holding is none. That's all it does. I mean, if you don't have a return in a statement. Now we can also look at. So let's go back. Let's get that list back. Let's see how we can return something a little more useful than just a random number that doesn't do anything. But so this is a list of numbers, 1 with 5 numbers, and I want to get the middle number, right? So I want to be able to get the middle number. Give me middle. So let's call it that. The middle index in this case will be, let's see what happens if I type in len 2, right? Not 2, x. So I want to be able to get 0, 1, 2. I want to get 2 in this case, right? So let's divide that by 2, middle index. We can remove all this, and then we need to call the function obviously for it to work. I'm going to print middle index as well, just to see what it is. So it's holding 2.5, and we know that indexes cannot be floating point. They have to be integers, right? So what we have to do, let's convert it into an int for now, and let's see if that works. So now we get 2. Okay, that works. Let's see what if it's 4 numbers, if it's an even number of not len. So let's see 1, 2. So now we wanted to not print anything, but we'll look at that in just a sec. So for now, let's say we just say if len of x modulus 2 is equal to 0, basically saying that it is even. Now we want to do this when it's odd. Okay, do this. Else print odd. We'll have to add the colon here too. So here we're checking if the len of the list is odd, then give me the middle index. Otherwise, just say, oh, it should be that it's even. List is even, right? So let's do that. Okay, so it gives me 2. If I make it 4, it says list is even. Now, once again, we can assign it a value. Okay, list is even. Middle index, right? That's what we want. If it's middle index is seen, I'm gonna return the middle index. Okay. If it's not, then I'm just gonna say -1. -1 because we know indexes start at 0, so -1 cannot be a thing. So let's see what happens now. Oh, I changed the name of the function. That's why. So if I do this now, x, and then I print x -1. X is now holding negative. Maybe we shouldn't use x for everything, right? Let's try y. So x is now -1. But if I change this to a 5, let's say, which is an odd number of items, it gives me 2. So notice how I have 2 return statements in the middle index, in this function, right? But only one of them gets executed, and as soon as one of them gets executed, the second one doesn't even get to run. Now this is kind of obvious because only one of the blocks of code runs. Let's see if I say just a function called gimme, and let's say call it return 1, return 2, return 3. Now these 3 are statements one after the other, right? Technically, all we're going to get is just the first one. As soon as the first return runs, it doesn't matter what comes after because it's going to exit the function. Let's see what happens. So it's going to be just 1 every time, nothing else. If I change this to a print even, it's not that it's not returning anything, it just exits the function. It doesn't, after this statement gets executed, it's as if these blocks of code, these statements don't even exist in the function. That's it. It just exits the function, and that's how we know that as soon as we run the return statement, the function exits out of the block of code. Now let's have another. Let's say we have a list with, instead of having ascending numbers, let's have something like random 3 7 1 7 3 9 0 2. So now I want to know, give me bigger than 5. So notice how I'm giving the functions the name that sort of reflects on what they're going to do. That kind of helps. You don't want to just call your function. Like I could just call it function and call function. That would work too. But instead of doing that, it doesn't really help with the readability. If someone else is going to read your code, it's going to help to describe what the function is doing with the name of the function. And it's going to help you as well, because if the name implies what the function does, then it's going to help you remember the name as well. So let's say I call it that. Let's do this. And then in the code I say if, let's go through and loop, if for each in x list to return, this is going to be an empty list, right? For each in x, if each is bigger than x, then list to return dot append each. No, that's not what we wanted. We said 5, right? Bigger than 5. Okay. So now at the end of this, we can return list to return, right? And then let's just call this function, okay? And then print y. So just by looking at the code, can you tell what's going on? We have a list here that's x. We are going through each item in x, and then we say if that item is bigger than 5, append it to another list called list to return, and then return that list right here, okay? 6 7 7 9, right? So I only get the numbers that are bigger than 5 in this case, which is 6 7 7 and 9. So you can return lists as well as tuples as well. This could work the same way with tuples, but then you can't really add and append to tuple, so it would just be like you would have to give out the tuple at the end with all the values. So this works with that too. So that's it for this coding lesson. I hope you understand how return works, and let's look at the problem now for this lesson. So the problem for this lesson, I make a program that asks the user for 5 numbers. Let's say I give it 3 and then 7, and what it's going to do is going to print the numbers I gave. So there's a list that I'm adding these numbers to, and then I have 4 functions in my program. One to get the sum of the list, one to get the average of the list, one to get the maximum number in the list, and one to get the minimum number in the list. these are 4 functions, and then at the end I just print out sum and then call the function, and then the function returns a value, and then that gets displayed right here. So these are 4 print functions, and inside the print function I have 4 functions. I believe this is called getSum, this is called getAverage, this is called getMax, and this is called getMin. So see if you can figure this one out, and I'll show you my solution in the next video.